Hello everyone, and a warm welcome to today's PV Tech webinar in association with Trina Solar. My name is Ben Willis. I'm consultant editor at Solar Media, which publishes PV Tech and Photovoltaics International, among other industry-leading publications. Today, we're going to take a close look at the emerging trend of 700 watt plus PV modules. If there's one constant in the fast-moving sphere of PV technology, it is change. Out of a necessity to remain competitive, not just with each other, but with rival energy sources, such as fossil fuels and other renewables, PV manufacturing companies are not afforded the luxury of being able to sit still for long. The drive towards greater efficiencies and therefore lower generation costs is an ongoing challenge for the industry as solar increasingly cements its status as a cornerstone of the emerging low-carbon energy system. With this picture of ever-evolving technologies, within this picture of ever-evolving technologies, one key detail is the size and power of the modules themselves. Over the years, the industry standard for module power ratings has steadily gone up. This is partly because of the greater efficiencies offered by new cell technologies, but also due to the increasing size of wafers. From 2018, the switch to mono-PERC technology brought with it a proliferation of new wafer types as manufacturers sought to optimize costs. And by 2019 and 2020, there were numerous formats available on the market, including the 210mm large format wafer. Thanks to the shift to large format wafers and the mainstreaming of high efficiency N-type cell technologies such as TOPCon, the power output of PV modules is now greatly increasing from 600 watts only a short time ago to 700 watts plus today. As the solar industry seeks to continue driving down the levelized cost of solar energy, the deployment of 700 watt plus modules in utility scale projects looks set to become a defining trend over the next few years. As one of the world's largest module manufacturers, Trina Solar is unsurprisingly at the forefront of this emerging generation of large modules. Last May, the company unveiled to the market its first 700 watt offering with the launch of its Vertex N 700 watt plus module series. Mass production of the module began later in the year, marking Trina as the first volume module manufacturer to produce 700 watt plus modules at scale. Trina has also taken a lead within the industry, announcing at the end of 2023 the formation, along with several other leading module manufacturers, of an alliance dedicated to standardizing the design of modules larger than 700 watts to ensure they dovetail with the existing balance of system hardware used by the industry. In the presentations we're about to hear in this webinar, we will learn more about the latest developments in PV technology and how 700 watts plus is emerging as a new trend in the N-type era. We'll take a close look at Trina's latest Vertex N 700 watt plus modules and the advantages they offer in the field. I'm pleased to welcome three expert speakers who will be our guides through this critical topic. Timmy Chan, an analyst at TrendForce, who will walk us through the latest trends in advanced PV technology. Following Timmy, Leo Tang from Trina Solar will take a deep dive into the Vertex 700 watt plus module itself, exploring details around its design, performance and reliability. Then we'll hear from Shiguo from Trina Tracker, who will examine the challenges of matching larger size modules with trackers in utility application scenarios. Finally, we'll open the floor to questions from you, our audience. As always, this interaction is very important to us, so please put your questions for today's speakers in the questions tab on the right-hand side of your screen, and we will do our best to answer them in the Q&A session after the presentations. So, without further ado, I'd like to hand over to our first speaker today, Timmy from TrendForce. Thank you very much.
Thanks, Ben. Greetings to everyone in the solar PV industry. I'm Timmy Chan, and analyst at Energy Chain of Chainforce Consulting. It brings me great joy to present today's insights on evolving chains and advanced technologies across the global solar PV industrial chain. Today, we would like to share with you the technology development in polysilicon wafer, cell, and module segments. For the first part, I will introduce the content related to silicon and wafers. The production of the N-type polysilicon is expected to constitute approximately 60% of the total polysilicon production. With a surplus in the polysilicon market, the stability of the P-type polysilicon prices is challenged. Whereas the pricing of the N-type polysilicon depends on customer demand and the actual growth rate of high-quality N-type polysilicon production. The wafer capacity is projected to reach approximately 1,194 gigawatts by the end of 2023, reflecting a notable 29% year-over-year increase and indicating oversupply in the wafer segment. However, due to decreased profits throughout the entire industrial chain and limited investment and financing channels, the expansion of capacity is expected to slow down. Secondly, from Q4 of 2023 onwards, the demand for the P-type wafers has declined rapidly, and the wafer production is swiftly transitioning to the N-type. 2024 is poised to witness a substantial increase in the market share of the N-type wafers, with solar to 66%. N-type technologies are driving the shift towards thinner and larger wafers, emphasizing a superior price-performance ratio. By 2024, large format wafers are projected to comprise over 98% of the wafer capacity, with the capacity of M6 and smaller format wafers set to be phased out next year. The advent of the rectangular wafers has successfully overcome the efficiency constraints of the M10 square modules. 9 leading module enterprises reach a consensus to standardize medium format modules for rectangular wafers. Simultaneously, manufacturers are accelerating the launch of the rectangular products in the second half of 2023, with predominant choices leading towards G12 rectangular formats. In the second part, I will discuss the advancements in cell technology. In 2024, the N-type cell capacity is projecting to reach 1,078 gigawatts. Meanwhile, the N-type cell capacity is set to come online rapidly, with expansion reaching its peak in the next 2 years, making the onset of the technology transition from P-type to N-type cell technology. We anticipate that the 2024 can witness the TOPCon cell capacity reach 909 gigawatts. In 2023, numerous manufacturers make extensive investments in TOPCon capacity, gearing up for the mass production of the N-type cells in the following years. We can analyze the TOPCon technology in the following stages. In the stage 1 from 2021 to 2022, TOPCon production predominantly originated from the pilot line. Moving to stage 2 in 2023, manufacturers achieved mass production. By stage 3 post-2024, advanced capacity starting yielding exists returns during the technical transition. Beyond 2026, high-efficiency production gradually exceeds demand. We expect that TOPCon cell production will comprise 70% of the total cell production and is expected to remain the mainstream route for the N-type technology within the next 3 to 4 years. The chain towards producing larger cells is a distinct developmental pathway, and by 2024, the production of the larger size cells is poised to encompass 99% of the total cell production. Specifically, the percentage of the M10 cells capacity has been gradually decreasing since 2022, will drop to around 16% in 2024. Conversely, the capacity of the G12 cells will see a substantial increase, reaching 83% and solidifying its position as the mainstream size. Customer demand has increased, inducing a rapid increase in the market share of the N-type modules. The expectation is that the market share of the N-type modules will soar in 2024, reaching around 70%, a significant jump from the 27% in 2023. As the industry experiences a decline in the chain price, enterprises with integrated TOPCon capacities are poised to gain more profits, differentiating them from the Tier 2 and the Tier 3 manufacturers. Continued expansion by both new and existing players leads to a sustained increase in the module capacity, which is expected to reach 1,411 gigawatts by the end of 2024. The rapid expansion of overseas module capacity continues. However, Chinese leading integrated capacities still hold a distinct advantage in cost efficiency, brand recognition, and the adoption of new technologies. It's expected that the global module competition landscape is unlikely to undergo significant changes in the short term, with Chinese companies remaining dominant. Projections suggest that the production capacity of large format modules will soar to 1,372 gigawatts, capturing an impressive market share of 97%. In contrast, the market share of the M6 and the smaller format modules is expected to be a modest 3%. The growing proportion of the N-type modules is driving an increase in the penetration rates of the bifacial modules. It's expected to significantly bolster the market share of the bifacial modules by 2024, soaring to approximately 51%. Explore the products showcased by manufacturers at various solar PV exhibitions, and there's something noteworthy. Many manufacturers renowned for their M10 signature format have introduced G12 rectangular modules. This suggests that the G12 rectangular N-type modules are gradually emerging as the primary choice for the future. Additionally, concerning the development of capacity for rectangular wafers used in producing medium format modules, the second quarter of 2024 is expected to be the peak period for the capacity online. Therefore, in the second half of 2024, we anticipate a substantial increase in the market share of rectangular modules, particularly the N-type M10 and the G12 rectangular formats. N-type modules bring a variety of formats, ensuring adaptability across different scenarios, from distributed solar systems to utility-scale PV power plants. Bifacial modules take center stage in N-type module products, especially the M1054 or the 72 glass backsheet and bifacial modules, along with the G1260 or the 66 bifacial modules. The M11 rectangular 72 format bifacial module has a maximum power of 630 watts, while the G1266 module adopting TOPCon and HJT technologies can reach a maximum power of 720 watts. With their remarkable potential, G12 products have become the industrial standard choice. With the mass production of Trina Solar's N-type TOPCon modules exceeding 700 watts, the G12 format plus N-types combination has led the industry into an era of power levels exceeding 700 watts. Observing the format of the N-type module products from various enterprises, HJT module products predominantly feature the G12 size, while the TOPCon modules mostly utilize the G12 rectangular and the M11 rectangular size. N-type modules configured with the G12 rectangular format have higher power output compared to those with M11 micro-rectangular formats. Notability: the standard dimensions of the G12 rectangular modules have become a popular choice among industrial leaders like Trina Solar, Jinko Solar, and JA Solar. These companies have already announced their timelines for mass production and order intake. Trina Solar achieved mass production in the first half of 2023, and the JA Solar began selling module products at scale from Q3 2023, and the Jinko Solar is slated to introduce rectangular module products starting in 2024. Furthermore, Trina Solar has unveiled pre-release upgrades for 2024 with large format module power reaching 720 watts, and medium format modules boasting a power output of 625 watts. In conclusion, firstly, the N-type wafer market is poised to claim a 66% share in 2024, and the large format wafers will nearly dominate the total wafer production, reaching nearly 99%, with rectangular wafers progressively dominating production. Second, the PERC cell capacity will be phased out faster, and the N-type TOPCon cell will be mainstream technology in the next 3 to 5 years. The production proportion of the G12 or the G12 rectangular format modules is projected to climb further, reaching around 83%, establishing it as a mainstream cell size. Finally, the N-type's market share anticipated to rapidly rise to 70% in 2024. The capacity proportion of the large format modules is set to surplus 95%, with G12 rectangular potentially become the mainstream rectangular module formats. The mass production of the N-type modules is expected to accelerate, with G12 plus N-type modules achieving a breakthrough power level of up to 700 watts. Here's my presentation today, and thank you all for listening, and have a nice day.
Thank you very much, Timmy. That was a really interesting oversight of what's going on in the market at the moment. Some lots to take out of that, so thank you. Regrettably, we still seem to be having some technical issues with our Leo, who should have been our second speaker on this webinar. So we're just trying to get a connection with him at the moment. So we'll have a slight change to our scheduled running order, and we'll move on to what is scheduled. Shi Guo, who would have been our third speaker. She is Trina Tracker product manager, and he's going to look at how larger format modules such as the Vertex 700 watt plus dovetail with balance of system hardware. In this case, he's going to look at the Trina Tracker Vanguard 1P G2 tracker. So Shi, over to you, and we'll hope that we're able to get Leo on the line in the meantime. Thank you very much indeed.
Okay, thanks for your introduction, Ben. Hello, everyone. I'm Gucci, the product manager from Trina Tracker. Thanks for having me here. Today, I will introduce Vanguard 1P upgraded version and the Trina 710 watt N-type module solution. And my speech includes 2 parts. So firstly, I'd like to introduce photovoltaic tracker industry. As we know, Trina has been in the photovoltaic industry for several years. So through the summary of historical projects, communication with third-party companies, and the understanding of regional policies, we believe that the tracker market capacity will gradually increase. In terms of global market, with the promotion of IRA, the United States is still the largest market for tracker, with the marketing capacity of more than 50%. And in Europe, Italy have introduced the agricultural photovoltaic related policies. So we think the tracker demand will bring a certain increase. And a Middle East country, they have introduced the new energy targets to reduce the impedance of oil exports. So tracker will be more favored in Middle East. Finally, in China, photovoltaic installed capacity continue to rise, and the requirement for trackers for a grid-friendly protection is going. Okay, we identified 4 major markets for tracker. Yeah, it is American, Europe, China, and Middle East Africa. So as shown as this slide, in addition to the European market, in the United States, Middle East, Africa, and China, the most of tracker application scenarios are flat terrain, such as plains, desert, etc. After we know the market distribution and application scenarios, we also visited and discussed it with our clients. So we summarized the requirements from customer. The first priority pinpoint is that for flat terrain, how to achieve the lowest system cost. Yeah, it is a good question. From the viewer of a tracker structure design, it is necessary to break through the limitation of length. Because of flat terrain, longer tracker can make the best use of land resources. And from viewer of product combination, yeah, for example, tracker and module, making full use of tracker design length, it can reduce the cost of the controller and drive system. As shown as this table, Trina upgraded Vanguard 1P tracker is equipped with the NEG module, can utilize 93% of design length. So we can see the power per tracker is also higher. Yeah.
I'm sorry to interrupt you. We're getting a bit of interference on the sound, so I don't know if you're using a headset or if you can adjust that or move a bit closer to your microphone. We're getting a lot of static and noise, so if you could maybe try and adjust that, that would be great. Thank you. Sorry to interrupt.
Okay, thank you. How about now? It's good. It's okay. Okay, let me continue. Let me continue. Good.
Okay.
And with about the above section, yeah, to fully use the tracker design length can dilute the cost of controller and drive system of the tracker. Okay, maybe some friends will ask me a question. Yeah, the tracker is longer, the module size is larger. So how to ensure the stability of this system? Okay, next I will answer this question. As shown as this slide, with the development of module technology, the size of module increases as the power increases. And what are the effects of the module size increase on the tracker structure? As shown as this picture, in the structural calculation of tracker, we mainly consider 2 parameters. The first one is the pressure on the module. The second one is the torque on the tube. Those 2 data are proportional to the module size. So upgraded Vanguard 1P not only use the design of rounded edged tube to improve the bending resource of tube, but also we use the multi-point drive system. Okay, as shown as the picture below. Yeah, the green triangle shows the torque distribution on the tube. Yeah, this triangle. So it means that when we use multi-point drive, can reduce the peak torque and make the torque distribution more uniform. So when the tracker carrying large modules, it can provide enough holding torque to ensure the structure stable. Okay. And from the formula, we can see that in addition to module size, pressure and torque are also related to GCN and GCM and DAF. So those data are all obtained through wind tunnel test. In another word, the more accurate the wind tunnel test results are, the more accurate the calculation results are. So a credible testing organization and rich testing item are very important. As we know, CPP is a leading third-party wind tunnel test organization. We cooperated with them to make the wind tunnel test report for our tracker. The report includes 5 tests. The first one is pressure study. Its main output is GCN and GCM. The second test is free vibration test. In fact, it is more like a data analysis. So its output is DF. The third and fourth test will support our R&D team to confirm the protection strategy under extremely weather. The final one, the fifth one, is slope study. This test result can help our engineering team make the layout for a project. But it needs to be noted that wind tunnel test is only a database, not a certification. So how to use this database is more important. Okay, so how does Trina team use wind tunnel test report? I prepared a protection strategy here. So the first one, the hail protection mode needs to be turned on manually. Then the tracker will rotate to a special position, ensure that the module direction and the hail falling direction are parallel as far as possible to reduce the vertical contact area between module and hail. And about the wind protection, when I visit our client, they always ask me a question. Yeah, how to ensure that the stability during the time when the module rotate from tracking angle to the stone position. Trina R&D team created the 3 levels wind protection strategy by limiting the tracking angle to reduce the time it takes to enter the stone position. And as we know, in Europe, United States, the labor cost is very high. And the installation environment in Middle East is complicated in summer, because it is very hot, right? So the client's third pinpoint is how to reduce the installation time and increase the power generation. First of all, Trina's patent spherical bearing not only do not require calibration during torque tube installation process, but also it can release the stress when the post sync. And our R&D team also created the innovative multi-motor system. So compared with the traditional mechanical multi-drive system, it can reduce 34% components. Yeah, because this multi-motor system without any transmission bar, without any bar holder or bearing, yeah, we just need a main TCU and a slave TCU control 2 different motor. That's enough. So firstly, it can reduce the labor cost because the less components. Secondly, it also can avoid so many mechanical wrist points. The third design, yeah, we call it shrink tube. It is special for the tube connection. Compared with the conventional clamp connection method, our shrink tube without any clamp or a bolt and nut, we just need 12 rivet to lock the tube together. Okay, that's enough. And this design have verified on more than 100 megawatt project. So it is a safer and more convenient solution. Trina Tracker self-developed control system, yeah, it includes the tracking control unit, TCU, and the tracker side SCADA, Trina Smart Cloud, and the smart tracking algorithm, SuperTrack. TCU, yeah, this I think it is a brain of tracking system, and its ingress protection level is IP65, so it can operate in desert or some heavy rain scenario very well. Trina Smart Cloud, it is a tracker-side SCADA. Its alarm function and the digital MAC function can effectively reduce the O&M cost. But maybe some friends will ask me, yeah, every project owner, every customer has their own station-side SCADA. Why do they need a tracker-side SCADA? Yeah, because the tracker-side SCADA can monitor some risk point that cannot be found by visual inspection. For example, the motor voltage and the motor current. Yeah, so tracker-side SCADA can monitor every tracker status. Okay, the final software, smart tracking algorithm, SuperTrack. It can increase the power generation under cloudy day because SuperTrack has two core algorithms. The first one is smart tracking algorithm, STA. It can increase the power generation on the cloudy day because in the cloudy day, there are all the diffused irradiance are not direct irradiance. So if our tracker, if every motor, if every modules faces on, it's not good because it cannot fully use the irradiance, diffused irradiance. But if we have the SuperTrack, it can control the module to a special position. Yeah, it can get more reduced irradiance to increase the power generation under the cloudy day. The second core algorithm of SuperTrack is Smart Backtracking Algorithm, SBA. It can reduce the power loss due to rotor shading. Yeah. Because in the backtracking process, it is the shadow is very long. If in the uneven terrain, yeah, such as the picture. It is easy to make the shading due to row to row. So if we have super track, SBA can control the tracker, every tracker to a good position, avoid the shading, and to increase the power generation, reduce the power loss due to rotor shading. Okay, in summary, Trina Tracker can provide a smart tracking solution, include not only software and hardware, but also the product and the service. Thank you very much. That's all from my side. Okay.
Thank you very much, Xi. That was great. Yeah, thanks for stepping in. I'm pleased to say that we've got Leo Tang on the line now. So let's keep our fingers crossed that is all. Those are all the technical problems we're going to have. So Leo, very glad to welcome you, and we look forward to hearing what you have to say with a close look at the Vertex N700 watt plus module. So Leo, over to you. Thank you very much.
Thank you all, and hello everyone. I'm Leo Tang from Trina Solar's Global Module Product Management Department, and today I will discuss about our fully upgraded 700 watts plus modules future forward. And as we are all aware, the global push towards carbon neutrality is reshaping the energy landscape, with renewable energy sources playing an important role. Elena predicts that by 2050, to limit global warming within 1.5 degrees, solar power installation capacity need to exceed 18,000 gigawatts, accounting for 94% of clean energy. And this shift underscores the transition towards a new energy system predominantly fueled by renewables, and cost reduction and efficiency improvement, leading to a continuous decrease in the levelized cost of electricity. They remain central themes in the PV industry, following the increase in the solar installation capacity. And the Bloomberg NF reports an 85% reduction in LCOE for utility from 2010 to 2023, making solar energy the most affordable power source in the future. And the solar power is now at a tipping point of becoming a mainstream energy source. And one might wonder about the continuous decline in LCOE. It presents the total cost of a solar project divided by its annual electricity production, encompassing initial investment, equipment, residual value, operational costs, and interest. High power, high efficiency modules contribute to balance of system saving, helping clients save on initial investments. Moreover, modules with high output and reliability safeguard customers' value throughout the product's life cycle and enhancing the total power generation. And as the industry's advancement in silicon wafer manufacturing, in large wafer sizes, high efficiency cell technologies, and the improvements in system design, tracker, and in smart technology algorithm have all contributed to the continued reduction in LCOE. And the Trina Solar has been a pioneer in the PV industry for 27 years, driving technological advancements and leading the industry's evolution. We were the first to establish and develop the 210 plus N-type product technology platform, initiating the 700 watts plus module era. And the Trina Solar leads in several high-efficiency industrial technologies, including like selective emitter PERC before, multi-bus bar, bifaciality, dual glass, 210 large wafers, and now Trina Solar's iTopCon technology. And from PV Infolinks, a trend report, we see that M6 and smaller technologies being entirely taken place by larger wafer technology. The 183.75 micro rectangular cell wafer replaced 182 times 182 cell quickly, and 80% or more new TOPCon capacity is rectangular cell, and the 210 large wafer has become the ideal cross-generational technology platform, bringing PERC to TOPCon and even to HJT in the future. And in 2020, Trina Solar led the establishment of the 600 watts ecological alliance with numerous PV companies, and now under collaborate innovation within the entire ecosystem, and the industry is rapidly moving towards a new direction of 700 watts plus. And Trina Solar, in partnership with leading companies in the PV industry, has created our 700 watts plus PV Innovation Ecological Alliance. Looking to the future, we aim to create value for customers and drive higher quality development in the PV sector. And here is a milestone of our 700 watts plus TOPCon modules in our PV industry. In last year, 24th of May, we globally launched our new generational iTOPCon advanced technology. And then last year, 18th of August, we officially announced mass production of our Vertex 700 watts plus TOPCon modules. And this year, 28th of February, we upgrade our 700 watts plus modules to 720 watts due to upgraded iTOPCon advanced technology. And now Trina Solar takes lead in the new era of solar energy. And here is the secret as to why we can achieve such a high power based on our 210 plus N-type TOPCon platform. And based on our 210 platform, we using our industry-leading mass production technology for 210 wafers, along with half-cut technology to reduce hot spots and the non-destructive cutting technology to lower risk of micro cracks. It showcases our commitment to efficiency and reliability. And the multi-busbar technology strikes a perfect balance between efficiency and reliability, while high-density packaging technology further reduces the risk of micro cracks, enhancing module reliability. And on Trina Solar's N-type technology platform, we use our advanced cell technologies such as laser-induced firing, real planar reflector, a highly low real TOPCon structure, aging passivation technology, and this technology safeguard improvement in the cell efficiency. And also, Trina Solar holds hundreds core patent group of TOPCon technology. That means our TOPCon technology is globally risk-free. And here is our Trina Solar's product Vertex family, and our product covers all scenarios. Like for residential rooftop, we have our 555 watts modules. It's a golden size within 2 square meters, extreme design and leading power and efficiency. And also for commercial and industry, we also have our medium format. We have our 505 watts module and our 625 modules. They are and our 625 watts modules is the best partner for tracker. And also today's highlights: Trina Solar's NEG 21C.20 using 210 silicon wafers, achieving module power up to 720 watts and efficiency up to 23.2%, designed for optimal LCOE. And here is our technology roadmap. And it shows why Trina's Vertex family products can reach such high power and efficiency levels. And we have passed through iTOPCon and iTOPCon Plus phases. Now we are at iTOPCon Advanced platform, and I will explain this later. And in the future, we also have Ultra and Tandem iTOPCon technology. And we all know that behind every 0.1% efficiency increase lies the relentless effort of our technical team, and our TOPCon cell laboratory efficiency has reached 26%. And in our latest iTOPCon advanced technology, we have employed a laser. We have applied like a real planar reflector, 25% increases in internal dorsal reflectance, and highly low real TOPCon structure. We're using PECVD. It's 2 to 3 times higher than regular LPCVD. And also, we have employed laser-induced firing. By irradiating the cell with high-density lasers, we reduce contact resistance between metal and semiconductor, effectively boosting cell efficiency by about 0.3%. And also we have employed aging preservation technology, which enhances the overall performance of cut cells and improving cell efficiency by approximately from 0.15 to 0.2%. And thanks to this technological advancements, our modules can achieve 720 watts power and 23.2% efficiency with a 30-year warranty up to 85% bifaciality, a lower temperature coefficient of 0.29% per degrees, and our standard large format dimensions of 2384 times 1303 millimeters. And they feature expansion of low irradiance performance and PID resistance and lower initial and annual degradation rates. And for overseas transportations, our 700 watts plus modules innovatively utilize vertical packaging, positioning modules upright, and each pallet carries 31 pallets and allowing 18 pallets per containers. And compared to the white 278 pieces modules, this approach increases the loading capacity by about 16.5%, and we maximizing the container space usage. And here is our latest results of the value assessment published by UL Solutions. And in this case, they help us do the simulation in Rio Verde, Brazil. The DC capacity is 125 megawatts, and we compared our 700 watts NEG 20C.20 with 278 pieces and 72 pieces. And we can see that the module per stream for NEG 21C.20 with our Trina Vanguard 1P tracker, it's 71 pieces per stream, and for 72 pieces, and for 72 pieces modules, it's only 30, and for 78 pieces, it's only 28 modules per stream. And under the same DC capacity, higher efficiency and higher module power means that we can saving more modules under the same DC capacity. And here is the CAPEX results, and we can see that compared to white 2N type products, we can saving in like mounting structure, string cables, and also like AC equipments and the labors. And totally for CAPEX, NEG and our 700 watts modules can saving 1.6%. And this is power generation simulation compared with the white 2N type products. And we can see that we have a better performance in photovoltaic conversion and DC losses. And all of this contributes to a better LCOE. And we can see that after the final calculation, our LCOE is, and not only our CAPEX, but also our LCOE, it's compared to white 2N type products, it's better. And we're saving almost 1.8% in LCOE totally. And here is compatible with the mainstream inverters in PV industry, and now it's our 700 watts plus modules is suitable for almost all commercial rooftop, large ground mounted, and even mountain and highly land utility. And we have collaborate with almost all of the mainstream inverters in PV industry, like Huawei, Sungrow, Goodway, Sinan, etc. And of course, the reliability of our 700 watts plus modules has been validated by authoritative third-party labs, and our products has passed enhanced test by like third-party labs like ITC, CGC, and PVER with outstanding results. And we have been named best performer by PVER for 9 consecutive years. We have passed the enhanced test like summer cycling 600 times, like damp heat 2000 times, like enhanced mechanical load, etc. like this. And our 700 watts plus got excellent grades in enhancement tests, and also our 700 watts plus modules also endured the extreme cold in Mohe, China, and it proves that monthly electricity generation is 276 kilowatts hours, a system efficiency ratio of 100%, and shows its excellent performance under the 0 and the 43 degrees below 0 under the extreme cold environment. And the Trina Solar offers advanced N-type products, helping users achieving higher power generation and investment returns. And our products with accurate carbon footprint tracking and competitive features also enhance end users' green competitiveness, accelerating the achievement of carbon neutrality goals. And the Trina Solar is committed not only to producing clean electricity through PV modules, but also to ensure the manufacturing process is greener and more carbon efficient. And the Trina Solar integrates the principles of green, low-carbon, sustainable development into its strategy and producing eco-friendly products while continuously reducing energy consumptions and the greenhouse gas emissions, advocating for environmental protections. And here is certifications that we have got in low-carbon, like EPDS, like US Solution CFP, and ECS, etc. And here's some photos, typical photos that shows our 700 watts modules has been shipped globally, and you can see that we have the projects like in China 88 megawatts percent, like in Saudi Arabia, and like in Brazil. Yeah, that's why our 700 watts modules is designed for optimal LCOE. It has higher power, higher efficiency, higher reliable, higher power generation, higher LCOE, and lower LCOE. And all of this contributes to lower LCOE. And the Trina Solar implements a vertical integration strategy, extending from cell and module manufacturing to upstream silicon materials in the wafer stage, establishing a vertically integrated layout from ingot to wafer to cell and to modules. And in 2023, Trina Solar's module production capacity reached 95 gigawatts, with a cell capacity of 75 gigawatts, including 40 gigawatts of N-type cells. And we also have a silicon wafer capacity around 50 gigawatts. And we can see from the map that now we not only have several manufacturing bases in China, but also we also have overseas manufacturers like in Thailand, in Vietnam, in Indonesia, in USA, in Abu Dhabi. That's all. This concludes my presentation today, and thank you all for listening.
Thanks very much for that, Leo. Really glad that your connection remains stable. So very interesting insights there. We've actually only got a few minutes for questions now, so we'll turn to that section of the webinar for the closing few minutes. There was something that you talked about briefly in your presentation, Leo, that we've had some questions relating to, and that concerns the reliability question of the Vertex N720. I wonder if you could just talk a bit more about the reliability aspect of these new larger modules. Obviously, bigger modules means more weight, a larger size overall to handle in the sort of installation process. I just wonder if you could go into a little more detail about the reliability question with regards to these larger modules, please.
Yes, of course. Yeah, I think the reliability of the modules is one thing that's most important for our customers. And I think in our 700 watts plus modules, someone may have the concern about the weight, about the big size of the modules. But in our reliability part, these modules we're using like dual glass, and we enhanced the frame of the modules, and it's 2 millimeters dual glass frame, which protects the modules from the water, like the arrow, like the duster, like this, and it's also compatible with the mainstream tracker and the mounted structures. And also we have passed the industrial enhanced tests, like mechanical and like dynamical and static mechanical load. And we can see that from this slides, we have passed the dynamical and the static mechanical load by ITC, and after that we passed the thermal cycling and HF and the HF tests.
Okay, thanks very much. Yeah, a question I guess this would probably also be for you as well, Leo, with regards to when the N700 watt plus module will be available for modeling on PV cysts. Obviously, it's pretty new technology, so I just wonder if you have any insights on that question, which we've had come in.
Yeah, I think we have published our latest PAN file for our 700 watts plus modules, and if our customer want running these modules in PV cyst, please ask our sellers, and I think they will send you the latest PAN file of our 700 watts modules, and then you can run these modules in PV cyst.
Okay. Thanks very much. I'll do one more question for you, Leo, and then one for Shi. With regards to the Trina Solar's technology roadmap, I mean, you talked about increasing size. Also, I think there was a slide there about your roadmap and new technologies that you're likely to explore in the future. Can you talk a bit more about the technology path, your roadmap, and what you're likely to look at in the future? Heterojunction back contacts, perovskites, any of those more exotic technologies, should we say?
Yeah. And about Trina Solar future technology roadmap, and we all know that now it exists a lot of technologies like HJT, like BC, and maybe in the future like tandem and HPC, TPC, like etc. I think Trina always stand in front of the whole PV industry, and what I can say is now we are preparing, and we are doing all we can do to do the preparations and to do the storage of the technology. And now we are starting all of these technologies, and finally, once we find it's best from the not only from the efficiency, from the power, but also from the customer values, and also like a mass production, and we will choose that one. but until now, and then in the recent future, TOPCon is still our mainstream technology.
Great, thanks very much, Leo. So question now for Xi, regarding the recent upgrades to the Vanguard system. It's obviously, as you described, a longer tracker now. I wonder if you could talk some more about how this feature, the length of the tracker, benefits modules that are larger than 700 watts in size, seeing as we now seem to be moving into this era of larger modules. How developments such as the elongation of the tracker, as in your case, how that benefits the larger modules.
Okay, thank you, Ben. Let me introduce what is the benefits or advantages of the product combination of upgraded Vanguard 1P and the Trina 710 watt N-type module. First, from the technical side, from my presentation, I always say how stable our tracker and how smart our algorithm. But to be honest, the main power generation component is the module. But Trina, it is only one company with the module business unit and the tracker business unit all over the world. So I think our tracker R&D team is understand the module very well. So our algorithm and the tracker can provide the service for module very well. And from the structure design viewer, thanks to our multi-motor system and the damper system, our tracker, the maximum length of our tracker is 140 meters. So it can carry 3 strings or 4 strings Trina modules to fully use the land resources to reduce the total cost for client. Finally, from the commercial side, if client choose Trina module and tracker, they just have one communication window. It's Trina. So I think it is convenient for the after sales. Yeah, thank you.
Many thanks. I think we've just got time for one more question. So back to you, Leo, for the final one. I think you alluded to this briefly in your presentation, but it's a question concerning the carbon footprint of your products. I mean, in this case, the larger modules. How do you manage those? I wonder if you could talk about that. Obviously, this is going to become an increasingly important issue for solar manufacturers such as Trina. I think there's certainly in Europe there are plans for a carbon import policy, and I just wonder if you've got some thoughts on how you manage the carbon footprints of your products.
Yeah, Trina Solar integrates the principles of green, low-carbon, sustainable development into our strategy and producing eco-friendly products while continuously reducing energy consumption and greenhouse gas emissions, and advocating for environmental protections. And now we have our zero carbon manufacturers and also zero carbon modules, and also we have the low carbon footprint experts to help the expert team to help us to optimize our supply chain, optimize the whole manufacturing, the whole product for the footprint and for the carbon neutrality goals.
Great, thank you very much for that final answer there, Leo. So that brings us to the end of this webinar. We're out of time, sadly. So I hope you found it insightful and stimulating. A few of you have been asking about the presentations that you've seen today. Recordings of those and the slides you've seen will be emailed to webinar participants in the next few days, so look out for those. The full webinar will also be available in full shortly on the on-demand section on PV Tech, so again look out for that if there's anything you'd like to go over. So all that remains is for me to offer a huge thanks to Trina Solar for sponsoring this webinar, and also to our presenters today. Big thanks to you all, and yes, apologies again for the technical issues we had. Contact details of the presenters will be available on their presentations that you receive after the webinar, so I hope you'll be able to keep the conversation going with them. Thanks to all of you, our audience, for tuning in. A big goodbye from me and a thank you from all the team at PV Tech. Have a very good day. Thanks a lot.